Diane Mattingly. I am a junior chemie at Carnegie Mellon, and I'm working on the batteries portion of the Google Lunar XPrize. I'm working with the batteries to see if they'll survive lunar night, and the main way that I'm testing this is by simulating temperatures that you would see during lunar night, and I do this by placing the batteries in liquid nitrogen and testing their performance before and after to see what kind of performance degradation we see. When I test the batteries, I run charge cycles and discharge cycles, and that consists of hooking a battery up to a power source or to a resistor, and then I take readings every 30 seconds of the voltage, and then I plot power charts. And if I'm putting the batteries in liquid nitrogen, of course we have to be a little bit more careful and use PPE, and those are the fun days, I think. You're never quite sure what's going to happen, or something's going to rupture, that sort of thing. Well, I worked with fuel cells my freshman and sophomore year doing research, and so moving into batteries wasn't too big of a transition. Still working with energy sources, but hadn't quite worked with batteries in this sense now, and definitely learned a lot. I charge my MacBook a little differently now as a result, but working well. So definitely the most challenging part for me is because I'm a chemical engineer, I don't understand a lot of the electronics and the ECE computer science part of things. So I've learned a lot. I've learned what stepper motors are, what brushless motors are. I know a little bit more about coding now. I definitely have learned a lot about the ECE and robotic side of things, and it's a challenge for me sometimes because I don't always understand the terminology, but I'm really glad that I'm pushing through it and learning these things. So I guess the most thrilling adventure that I've had with Google Lunar X was the first time I put the batteries in liquid nitrogen, and we pulled them out about a week after we put them in, and we just set them in the room temperature, and maybe a minute later they ruptured, and one of the batteries actually shot out of the container that it was being held in. And we weren't quite sure what was going to happen at that point. We didn't expect them to rupture, obviously. And so that was probably a very high-intensity situation. But the best thing that came out of that was finding out, a week later, that when I hooked the battery back up to the resistor, that it still discharged and that it still was capable of holding a charge. And being able to accomplish that was pretty rewarding. So I got involved with the Google Lunar XPrize through a friend who was working on the project, and he was telling me that they were looking for chemies to work on the battery, and I said, well, I have a little bit of extra time, I'd love to do that. And so that's kind of how I got started on it, and I think it's a good choice. This team is going to win the Google Lunar XPrize because of everybody's dedication and broad range of knowledge that everybody brings to the team. So, while one person's working on, okay, well, how do we get the wheels to turn? Another person's working on the thermal side of it, and so everything's going to come together, and every aspect's going to be covered. So we're not going to get up there and have a factor that nobody considered before. And that's how we're going to win the Google Lunar